This is section 8.1, day 2 on vectors. Here we have example 4, operations with vectors. Draw a vector diagram of 3x minus 3/4 y. So here's x, there's y. Let's get some measurements on x and y. X is approximately 12 millimeters. So that's 12 millimeters, and we'll say that that's going straight right. Y, let's get y's measurement. And y is about 22 millimeters. Let's call that 22 millimeters. And let's extend y so we can get an accurate measurement on the angle. And if we're going to use kind of unit circle talk here, we'll go from the positive x-axis. That's about as level as I can get it. It looks like 51 degrees. So 51 degrees. And we're supposed to do 3x minus 3/4 y. So if I take 3 times x, that's going to be 36 millimeters. So we'll multiply the magnitude. So let's start off to the left here because we're going to go to the right. And we're going to go to the right 36 millimeters. So here's 30 and then 6 more. So this I'm going to label with 3 times x. And then we have to go 3/4 of y. Well, if I take 3 times 22 millimeters, that's going to be 66, and I have to divide that by 4. So that's 1, 4, 26, 16 is 24, 2 left. So about 16.5 millimeters. But we're going in the opposite direction because it says minus. So if we're 51 degrees from the positive x-axis, let's go 51 degrees from the negative x-axis. So here we have it all lined up, and I'm going to go 51 degrees. There's 51 degrees. And then now I have to do this 16.5 millimeters. So let's line this up. So 10, 15, and 15, 16.5. So maybe I go a little bit more. So this is negative 3/4 y. We've gone in the opposite direction of y, and we've multiplied the magnitude by 3/4. So now we need the resulting vector. So here's the resulting vector, and we go from the beginning to the end. So it goes in that direction right there. And then this is the 3x minus 3/4 y. Draw a vector diagram of each expression. Here we have a minus c plus 2b. So let's get some measurements. This one is 30 millimeters. 30 millimeters. B is, let's say, how about 12 millimeters? That's 12 millimeters. And then let's see what C is. I'm going to get this a little closer. So we have 22 millimeters. So 22 millimeters. Let's extend this so I can use the protractor a little bit easier. So extend that up. We'll extend that down, and we will also extend this one so I can get a better reading on it. So let's get A, the angle for A, and we're going again in unit circle talk. This is about as level as about as level as I'm going to get it. And we have about 48 degrees. So let's call this 48 degrees. B is upside down, so let's try to get this as level as we can get it. And that is 100, let's say 121, so negative 121 degrees. And with letter C, we have 116 degrees, 116. So we need A minus C. So I'll start with A. Maybe we start it over here. We need 48 degrees. 48 degrees. And 30 millimeters, so 3 centimeters. 1, 2, 3 centimeters right there. and then we need minus C. So this is A minus C. So I want to go in the opposite direction, and we'll go 22 millimeters. So let's get the opposite direction. And it was 116 degrees from the positive. So let's go 116 from the negative, which is about right there. And we have to go 22 millimeters. 22. So there's 10, 20, and 2. And then finally we have plus 2b, and b is 12 millimeters, so we'll make that 24 at negative 121. And it is plus, so we're going to go in the same direction. I need 121 degrees, so I'm a little off the map. Let's call it right there. Didn't plan that ahead real well. So there it is at the end, and we need to go 24 millimeters, so 10, 20, and 4. Now this right here is the resulting vector. There's the result. So this is A, this is minus C, and this is 2B. And then we have the result, which is A minus C plus 2B. All right, for B we have M minus 1/4 P. Let's get some measurements here. This one looks to be 22, so 22 millimeters at an angle of let's extend this. That way we can see the measurement a little bit better. This is at about, let's say, 50 degrees. So 50 degrees. And let's measure P. P looks to be 30 millimeters. 30 millimeters. And let's extend this one. There we go. And this angle looks to be at about 19 degrees. And let's go back to this one. I didn't mean 50. What I meant to say was at 130. So let's erase that and make it 130 degrees. Now we need M, so I need to go down here, about right there, and replicate M. So I need that 130 degrees. There's 130 at 22 millimeters. So 10, 22, there's 22 millimeters. And we need to go in the opposite direction as P, but just 1/4. So I need 30 and then divide it by 4. That's 7, 28, 7.5 millimeters. So let's go negative. Let's go not negative, but 19 degrees from the negative x-axis. That's about right, way over here. And then I need to go 7.5 millimeters. So there's 5, 6, 7.5, about right there. So this is the M, this is the minus 1/4 P, and then we need the resulting vector right there. So we have M minus 1/4 P. An airplane is flying with an airspeed of 310 knots on a heading of 050 degrees. If a 78 knot wind is blowing from a true heading of 125 degrees, determine the speed and direction of the plane relative to the ground. So we're going to go at 050 degrees, which is the true heading, so it's 50 degrees from north. And then we're going to go at 125. So if we start off to the left here, we should have plenty of room. And we're going to make 1 millimeter equal to 5 knots. If we take 310 divided by 5, we get 6, 30, 10. We get 62 millimeters, which is 6.2 centimeters. So I need to go 50 degrees from true north. We have 10, 20, 30, 40, 50. So right there is 50 degrees from true north, and I need to go 6.2 centimeters. So let's line this up. And we have 1, 2, 3, 4, 5, 6.2 centimeters right there. Then we need to take 78 divided by 5 because we're going to go 78 knots at 125 degrees. So that's going to be 1, 5, 28. That's 5, 25, 15 and 3/5. So let's say almost 16 millimeters. Let's find out where 125 is. Now, if this 0 over here represents 90 degrees from north, we have to go 35 more degrees. So 35 will get us to 125. And I need to draw this almost 16 millimeters. So we'll try to draw that as accurately as we can get it. So almost 16, 10, 15, almost 16, right there. So the plane is headed in this direction, but the wind is pushing it off course. So we want to find out the true path of the plane. So here's the true path of the plane right there. All right, so let's get the magnitude. And the magnitude is, let's say, 67 millimeters. So 67 millimeters. We multiply that by 5. 35, so 335 knots. And then let's get the angle. And the angle that the path of the plane is on is about, let's see, we got to go from 90, 10, 20, 30, 40, 50, 63 degrees. So 063 degrees. Two or more vectors with a sum that is a vector r are called components of r. While components can have any direction, it is often useful to express or resolve a vector into two perpendicular components. The rectangular components of a vector are horizontal and vertical. In a diagram, the force r exerted to pull the wagon can be thought of as a sum of a horizontal component force x that moves the wagon forward and a vertical component force y that pulls the wagon upwards. So there is a horizontal component and there's a vertical component when you are pulling a wagon. And the same thing when you are pushing a lawnmower. So we want to find what is the vertical and the horizontal force when we push this lawnmower. So let's start over here, right there off to the left. And we'll say that 1 millimeter is equal to 10 newtons. So we're going to draw this 45 millimeters or 4.5 centimeters at 56 degrees. So we have 56 degrees, and I need to draw this 4.5 centimeters. You can hear track outside practicing because it's raining out. 1, 2, 3, 4.5, about right there. And so now that's the force being exerted on the mower. What about its horizontal and vertical force? So let's line this up so that we're right at 90 degrees. So I think it's going to happen about right there. So we line this up with the tip of the vector, and that should be 90 degrees. So that's actually the length of the vertical component. So here we have the horizontal component. The horizontal component's magnitude is approximately, let's say, 26 millimeters, so 260 newtons, and the vertical component has a magnitude of about 37, so let's say 370 newtons. But that's what they want you to do. They want you to draw a diagram that shows the resolution of force that Heather exerts into its rectangular components. But if this is 56 degrees and this is 450 newtons right here, we could find it by doing cosine of 56 is equal to 260. No, it would be, well, let's say we don't know the 260. Let's say this is the x component, x over 450, and we could do sine of 56 is equal to y over 450. So we could find the values just using trigonometry. So So let's use the calculator to find the actual values. We have 450 times cosine of 56, and that's equal to 251. So we estimated 260. And then with 450 times sine of 56, we get 373. So we're a little closer on the vertical part.